In this class, we try to learn how to use the regression model or continuous dataset. So for this, initially we open the column where we will apply the codes. I already stored the code. So from here I click File and Upload Notebook and browse where I saved my code. This is the code for basic regression analysis. So in this regression analysis, initially we have to upload all necessary files. Pandas as PD, NumPy as ND. You can click here to connect. After manage session as a lot of open. After connecting, we'll run all the code sequentially. And we have to know the basics. There are different type of regression model has here like gradient boosting machine, XGB boost, light GBM, random forest, linear regression, cat boost. This is the some regression of a regression model. On the other hand, here is the basic performance analysis. Our performance measuring tools is MSE, MAE, RMSE, R square, PSNR, and SNR. These are the basic performance measuring tools in regression analysis. Uh, Here, a lower value of MSE, MAE. I mean, this is the E for error. So all of the error the lower value of MSE, MAE, RSME, and the higher value of R square PSNR, SNR considered the superior predictive performance, and the R square value basically lies between 0 to 1 at least, plus 60% or 0.6 to 0.9 or 9.9. This is the it indicates the model is performed okay, at least R square value greater than 0.6. So the code is connected. So initially we import all the necessary package. Then we have to upload the file. In our previous class, we already saw that how to clean our dataset, and definitely for further processing we have to use the cleaned dataset. So we upload here file, then name copy of this file name, and here we have paste the file name. Then here is the basic issues that everyone should know, like X and Y. X is the input section and Y is the output section. This is our clean dataset, and this is our column 1. For column 1, the indexing value is 0. For column 2, index value is 1. So index value 2, index value 3, index value 4, index value 5. So we have 6 input dataset, and it starts with 0 indexing value. So we have to put the 0 indexing value, and the number of column is 6, and the output value is in 6. In the output column is considered here as indexing value is 6. So we put here 6 and run this dataset. The first person of here the dataset. Initially, we will learn the dataset or train, that is known as train the dataset, and the remaining portion will be considered for testing them. So here we X train, X test, Y train, Y test, and the sample size is considered for test size is 20%. And let you can use random state from 1 to 10. Like from 1, when you use 1, the data maybe, if the train data starts from here, when you consider the random state 2, the initial starting point of data may be different. Definitely will be different, not from here. The 80% data is considered as the train data. But when you use random state 1, then if data starts from here to 80%, then the next time when you change the random state value, the data, the train data starts from different places. So that's why we will use initially random set 1, then 2, then 3, up to 10 fold analysis. Random set 10, this is known as 10-fold analysis. So here we run the, then here we print the y test value. The y test value is 35.37, then 22.52. This is the test value that already has in our file. I mean, in this file, the test value already exists. Now we will see, based on this test value, what is the train value. So here we use decision tree regression. If you want to use another model, then definitely you have to change this model name, and you can change here the hyperparametric or parametric also to get better performance. You can use any AI to know what is hyperparametric and for which model which hyperparametric is used. So then here we print the y prediction value based on this test value. So the first value was 35.37, but our prediction value is 30.81. The second value is 22.52 test value, and the train value is 22.65. So almost the value is closer with the test value. Then calculate the matrix, I mean MSE, MAE, R square value, and PSNR, SNR. So the value of R square we get 0.85%. I mean, it's a better result we get from here. But we sequentially you have to change the random is to 2, 3, 4, 5, up 10. And here is a plot for predicted value. Red is the actual value, and another value is the predicted value, and the value when it lies between the red line, it shows the better performance. So secondly, we have to change the randomest value 2, 3, 4, 5, and up to 10, and finally we have to average 1 to fold 1 value to fold 10 value, and we will use the average of 10-fold value for our analysis. Like let's say the randomest value 3, and see how the changes. Initial test value here is changed already. So the train and test starts from different places. For 19.33, the train value is 20.61, and here the R square value definitely will change 0.98. I mean 98% accuracy we will get when we use the randomistic tree. Similarly, the graph generated in here. But if we in this code, if we want to use, then definitely we have to use 10 times for changing the random state value. But here is another code where we already set, using one code you can get the 10-fold value at a time. So initially import all the package, and here a lot of model has that is used in linear regression. Linear regression is lasso, decision tree regression, random forest regression, SVR, it's etc. And then import the data set or data file. Here is our clean data set. Copy the name of clean data set and paste here. This is the similar 0 to 6. This is the initial indexing value, or 6 is the number of input column, and 6 is the indexing value of output column. Then load the data set, and here is the file that is automatically generated in left side from random state 1 to 10 with MAE, MSC, RSME values. So we run the code here already. A.csv file generated, and when you open this file, this is the 1-fold, 2-fold, 3-fold, 5-fold, 6-fold, 7-fold, 8-fold, 9-fold, 10-fold values. And this values is the first value of MAE. The secondly MSE value, this is the MSE. And thirdly, this is the RMSE, and lastly, this is the R square value. Almost we will get almost every time the performance is very better. R square value, maximum value of R square is 1 almost every time, so you'll get some better values. But we also get a poor value in I square value minus 105. This is not a good value result shows, but we have to use the average of this all four parameters. If we want to use, instead of decision tree regression, let's say we will use the linear regression. So we copied the linear regression name and change, only the change is here, model name, linear regression. Then you can use here the parametric that will definitely help to get better results. Then run the code. You can download file from here also. Let's see. Delete. Then for linear regression, we run the code, and the CSV file a.csv file is generated here. Here is the 10-fold value. This is the MAE, MSC value. This is RSME value, and finally this is the R square values. So using this code easily we can do the regression analysis. And finally, we will try to see another code. This is very important code, and every paper this figure we can use. So this was our first clean dataset, but from here we will use only base 20 set dataset. For 20 set dataset, we need to copy up to 21, because the first column is the name or heading of column. Then we place it another file. Copied, and the code is pasted here. Then we will delete after 21 column. So this is 21 column, means 20 set data set, and the remaining portion we will delete. Then we save the file. So in our new data set, 20 rows of dataset has, this is named as cleaned dataset copy. So in this is our third code, and here the code is connected. Then run the code. import pandas numpy matplot from sklearn, the model linear regression, and upload our new dataset. New dataset is named as cleaned data copy open, and the name is copied here and pasted here. This is the x and y, I mean input and output based on previous manner. Here the model is decision tree model. You can use any model from here, the regression model. So I will run this code, and this is the actual value, and for this actual value the predicted value is this. For actual, this is the predicted value, and finally a graph is generated. This graph we can use in our paper. And the red color shows the predicted value, and the blue color shows actual value, and all the actual and predicted value overlapped one another. So our performance is very good. Here, R square value is 1, and the MSE, MAE value is 0. So it indicates the analysis is okay. But sometimes using the raw dataset, this was a raw dataset. So using raw dataset, you cannot get the proper performance measuring parameters value properly. Like you can get the R square value 0.2, 0.3, 0.4. That at that time you have to do more or further analysis like feature optimization, data scaling. You have to do this type of two type of works before running this code. And in our the next lecture we will try to make understandable how to use the feature optimization or data scaling technique. So and for today's session we stopped here. If you need the codes, definitely leave a comment in comment box. We will share the codes that we used in our session.